This is a classic. You're flying in a plane, and the pilot decides to execute a vertical loop. In this case, the radius of the loop is 1,500 meters, so 1.5 kilometers. And the idea is, what is the force that's creating that centripetal force that's allowing the plane to go in a loop? And the idea is, when the plane is flying, obviously we have the force of gravity acting down. We have no normal force because it's not resting on a surface, but there's this force of the air that's created by the lift, the shape of the wing. You've also got, the engines. The plane has got its own thrust propelling it forward, and then there's this force of drag, kind of holding it back. And like we said in the previous problems, these forces are presumed all to be equal. Okay, but then this plane is just going to continue at a constant velocity in a straight line forever until some other force acts on it. So what happens is that the pilot decides to do this loop, and he changes the shape of the wing through his controls, and that causes this force of the air to get much bigger. So this air force of the air, increases, and then it's pointed towards the center of the circle. So what we're going to say is this is the force of the air that is unbalanced and allowing the force to be accelerated towards the center of the circle. So the idea is they want the force of the air to be zero at that point. So if I get rid of that force altogether, what's causing this plane to go in a circular loop? Well, don't forget that gravity is still acting on the plane. So if we can get the plane going fast enough so that it gets to the top, that air force can drop to zero as long as force of gravity is there to sort of pick up the pieces. So what we would say in this example is Fc equals the sum of the forces, which equals, in this case, there is only the force of equals mv squared over r, I would say. And then in this case, the sum of the forces, the only force acting on it is Fg, and that equals mv squared over r. Now we know on the surface of the Earth, Fg equals mg, so the mass of the plane times the acceleration due to gravity, and this is mv squared over r, so you can see that the masses cancel. If you were worried about the fact that there was no mass in the problem, it doesn't matter what the mass of the plane is. This is true regardless of its mass. So now we're just going to solve for v. V equals, you can do the math, but it's g times r. And when you plug in the numbers, you're square rooting, the g is 9.8, r is 1,500. Taking the square root of that, you end up with v equals 121 meters per second. So what does that speed mean? That means if this plane is going any slower, instead of making it around the circle, it's going to sort of come off. So it's going to come along here, and then it's going to sort of fall off the circle before it gets to the top. If it's going less than, this is if it's going, let me put a little note in here, if it's going less than 121 meters per second. If it's going more than 121 meters per second, and the pilot still wants to execute this same radius loop, you would then need to add an additional force, and that would be the force of the air. In this example, it would be the force of the air would come back into play, force of the air, and that would be required in order to make it around the loop. But if it just hits that sweet spot of 121 meters per second, it can just make it around the loop. And basically, this is the same example. Think about, what I want you to think about in this example is that skateboarder, Tony Hawk, going around an open loop. Tony Hawk going around an open loop. Okay, he doesn't need the top of the skateboard ramp, because when he gets to the top, he's using his force of gravity to complete the centripetal force that he needs to